All right, let's talk about AI. We're going to trace its incredible story, right? From just an idea, a concept, to this explosion of technology that's totally reshaping our world. So let's dive in.
I mean, it feels like artificial intelligence is just everywhere all of a sudden. It's changing everything. But you gotta wonder, how did we even get here? And, what's really going on under the hood? How does it actually work? To figure that out, we've got to start with the most basic question there is.
Okay, so first things first, what is artificial intelligence? Before we jump into the history and all the cool stuff, we really need to get on the same page. And it sounds like a simple question, right? But the answer, well, it kind of depends on who you ask.
So you've got these two main ways of looking at it. On one hand, you have the political or legal definition, right? The OECD thinks of it as this big machine-based system that takes in information, figures out what to do, and then generates outputs that can actually influence the real world. But then you've got the engineers, the people actually building this stuff. For them, it's a bit more technical. The ISO sees it as an engineered system that's built to create things, content, forecasts, recommendations, all for a very specific, human-defined objective. So one's about influence, the other's about a specific goal.
All right, so we have a couple of working definitions. Now let's rewind. Let's go way back. Because this whole idea of learning machines, it's not new. This wasn't something cooked up in a lab last year. Nope. This dream started decades and decades ago with some incredibly forward-thinking people. And here it is, the big one. Back in the 1950s, a guy named John McCarthy literally coined the term artificial intelligence. And his definition? It was so simple, but so ambitious. He basically said, it's about creating intelligent machines having the ability as humans do. Just, wow. Think about that vision for a second.
Then, just a few years later, came the idea that really changed the game: machine learning. Now, this was a massive shift in thinking. See, before this, you had to program every single instruction. But a pioneer named Arthur Samuel came along in 1959 and asked this brilliant question: what if we could give computers the ability to learn without being explicitly programmed? What if they could figure it out on their own?
So, if you want a machine to learn, where do you look for inspiration? Well, you look at the best learning machine ever created, right? The human brain. And that idea, that concept of brain-inspired computation, that is the absolute key to understanding everything that comes next.
So how do you actually do that? How do you build a digital system that's inspired by the brain? The answer is something called an artificial neural network. So let's crack one open and see how it works.
Okay, so this is what it looks like fundamentally. It's really just a structure of these interconnected points, or neurons, all organized into layers. The whole design is meant to mimic, in a very simple way, how our own brains process information.
Let's break it down. You have the input layer. This is where the raw data goes in. Think of it like the pixels of a photo of a cat. Then you have these hidden layers in the middle. This is where the magic happens. They perform all these computations to start recognizing patterns, like, that looks like a whisker, or that's a pointy ear. And finally, you get to the output layer, which gives you the final result, the decision. Yep, that's a cat. Now, the really crucial part is the connections between all these layers. They have adjustable weights, and by tweaking those weights, you can make some connections stronger and others weaker. And that is how the network actually learns.
But wait, how does it learn? I mean, really? It's got the structure, sure, but how does it get smart? Well, it's not magic, even though it can feel like it. It's actually a really clever and very repetitive process of digital trial and error.
The training process is actually pretty straightforward, but it's incredibly powerful. So, step 1, you feed it some data. Let's say that cat picture again. Step 2, it generates a prediction. It makes a guess. Maybe it says dog. Step 3, you measure how wrong it was. That gap between dog and cat is the error, which in the field they call the loss. And here's the cool part. Step 4, the network then adjusts all those connections inside to reduce that error. It's basically saying, okay, I was wrong, let me tweak things a bit, so I'm less wrong next time. Now, here's the thing. You do that millions or even billions of times, and that's how it gets so ridiculously smart.
Okay, so you might be thinking, this idea of a neural network sounds pretty modern. But believe it or not, the core concept has been around for decades. So let's take a quick trip through time and see how we got from this really elegant theory to the mind-blowing tools we're all using today.
So you have the big dream starting in the 1950s. And honestly, for a long time, progress was pretty slow, kind of simmering in the background. Then you start getting these key breakthroughs. In 1989, a network called LeNet actually learned to read handwritten digits. Pretty cool.
But the real game changer, the moment everything shifted, was 2012. A system called AlexNet, powered by GPUs, gaming hardware, just completely shattered all the records for image recognition. It wasn't just a little better, it was a quantum leap. And after that, the pace just exploded. By 2015, Google open-sourced TensorFlow, and suddenly this incredible power was available to pretty much everyone.
And that brings us right back to that big question, doesn't it? If these ideas are from the 50s and 60s, why is this all happening now? Why did AI suddenly go from a niche academic field to this in just the last 10 or 15 years?
The answer, it turns out, is a perfect storm. It was these three massive technological forces that all collided at just the right moment, creating what you could honestly call the AI Big Bang. Okay, so there were three essential ingredients for this AI boom. Ingredient number one, massive amounts of data. These neural networks are hungry, and the internet, with all its e-commerce and social media, suddenly provided this enormous buffet of information to train them on. Ingredient two, powerful hardware. It turns out that GPUs, the graphics cards that make your video games look so good, are absolutely perfect for the kind of math AI needs. And with cloud computing, that power became accessible to everyone. And the final ingredient, an open source community. Tools like TensorFlow were shared freely, which meant that researchers and developers all over the world could build on each other's work, accelerating everything.
And when you put all three of those things together, the massive data, the incredible hardware, and the global collaboration, this is what you get. The result isn't just a machine that can follow a simple program anymore. It's a machine that can infer, that can predict, and that can even create, in ways we are honestly just beginning to wrap our heads around.
So that leaves us with one final and kind of mind-bending thought. Those three forces we talked about, data, hardware, and the open source community, they aren't slowing down. Not at all. In fact, they're accelerating. So the real question is, as these forces continue to compound and grow, what unbelievable new abilities are going to emerge next?